Alright guys, so now that we know about diazo replacement reactions, we have to take that into account when we think about sequence groups. So as you guys might recall, sequence groups are groups that have the ability to alter the sequence of an aromatic synthesis, and they're groups that can be easily transformed from one type of director to another. Okay? And we have examples of this in EAS, but now we have diazo reactions as well that we have to take into account. Now here's another definition, guys. Blocking groups. What's a blocking group? Remember that a blocking group is a group that really only acts to direct the other reactions, and then it's completely removed. So the only way that you would know that it was there is because you can see what it did, but not because it's actually there anymore. Well, it turns out that now that we know about H3PO2 or hypophosphorus acid, that group is used to block the pair position and force orthosubstitution. How? Because we know that we can remove a diazo group with H3PO2. So that means that we can use diazo compounds as blocking groups and then easily remove them after. Okay? So let's talk about some that we already know. So Clemmensen reduction. Clemmensen reduction takes a meta-director, and when you react zinc and mercury over HCl, you're going to get an OP director. Okay, so that's a sequence group because I just changed the direction of the directing effects of my substituent. Side chain oxidation. So I know that I can oxidize an R group using KMnO4 and base and heat and acid. And I can oxidize it to a benzoic acid, meaning that it started off as an OP director and it ends off as a meta director. Okay? We know that another directing effect, or I'm sorry, another sequence group would be reduction of amide and nitro groups, okay? So in this case I'm doing a nitro, but amides can reduce as well. We learn more about that in your amines chapter, okay? So don't worry too much. But anyway, we know that reducing agents love to reduce nitro groups, so obviously we could use lithium aluminum hydride, and there's a few others that we've learned. You guys know my favorite. We could use the stannous chloride, right? And that would reduce my nitro to an aniline. But now here we go. Here's the diazo reaction specifically. So for diazo, I could start off with diazo. Notice that this is a meta director. Okay, because of the fact that there's a full positive charge. What type of director would that be? It would have to be meta, right? Because it's a strong deactivator. Okay? And after I change it out with the replacement reaction, I could make it into a donating group, or an ortho pair director. So can you guys think of a substitution, or I'm sorry, a diazo replacement reaction that could make a donating group instead of a withdrawing group? Can you think of one that would turn it into an ortho pair director? So just so you guys know, there's plenty that you could use, but one of the easiest would be, how about just water? What would water do? As an example, I'm just going to put here IE, because it's just an example. Water would turn my diazo into phenol, right? And once it's phenol, what kind of director is that? Orthopara. Cool? So you guys can see, and there's a lot of other ones that we could choose that are orthopara directors. And then finally, we have diazo substitution with a proton. So you start off with diazo, that's a meta director, but you could use it as a blocking group. So if you react it with H3PO2, you're going to wind up replacing it with H, and this is our blocking group. Because what you do is you block that site from reaction. So you can react something else somewhere else and then take it off. All right? So these are the things that we have to keep in mind when we do synthetic synthesis with diazo reactions. Okay, we have to keep all of these sequence groups in mind, all right? So let's move on to the next topic.